Okay, 7.2 is on applications of exponential functions. And I want to do enough problems on here so that you really get an idea of how to do these. They're not real hard because basically they give you the formula for the most part, but there are three different types of equations that we'll be going through. The first will be dealing with exponential growth and decay. Then we're going to talk about compound interest, and then we're going to talk about radioactive decay. So I'm going to do this video in three different parts so that we have enough time to cover everything. And if there's one particular part that you don't understand, you won't have to watch through the whole video to see the kind that, and go through the ones that you do understand to get to the ones that you don't understand. So I'm going to do this in three parts. So part one is going to be on exponential growth and decay. Now, on these problems, they're usually given with the formula P of t is equal to P0 a to the t. Now, you can think of this as P of t is the population as time goes by. So P of t is the population at time t. P of 0 is the initial population. And A is the growth or decay rate. We'll talk about that in a second. And then T, of course, would be time. So let's look at an example so you can see what we're talking about. It says, a biologist is culturing bacteria in a petri dish. She starts with 1,000 bacteria. All right, so that would be the initial population. If she's starting with 1,000 bacteria, that's what she's starting with. So that's the population at time 0. So she's starting with 1,000 bacteria. Then it says the bacteria doubles every hour. So that's going to be your A. So every hour it doubles. And notice here that time is going to be measured in hours. If it said that it doubles every 10 minutes or every minute, then time would be in minutes. Okay, but in this case, it doubles in every hour. So my A is 2 and time has to be measured in hours. And then it says, what will the population be at the end of 5 hours? So that would be our time, would be 5 hours. So the first thing it says is find the equation. So part A says, find the equation for the population at time t. So if we're looking for the equation of the population, we're just going to use this equation and we're going to plug in P0 is 1,000 and A is going to be 2. Now we want the population at time t, so I'm not going to use the 5 hours yet. So P of t is just going to be P0, which is 1,000, times A, which is 2, to the t. And so that's my equation, and this is how you would write it on the first part of this question. You just write P of t equals 1002 to the t. Then it says, part B says, determine when the population would reach 16,000. So when will population reach 16,000? So this is giving the population at some time that we don't know, but we're trying to figure out what t is. So notice that here they're giving you P of t is equal to 16,000. So coming to our original equation, that would give us 16,000 is equal to P0, 1,000, times 2 to the t. So now we have an exponential function that we need to, or equation that we need to solve. So the first thing that I have to do is isolate this exponential part of the equation. And so I'm isolating the 2 to the t, so I need to get rid of this 1,000. They're multiplied, so I'm going to divide both sides by 1,000. So 1,000 goes into 16,000 16 times. So I get 16 is equal to 2 to the t. So now I want to make my bases the same. So 16, 2 times 2 is 4, times 2 is 8, and then times 2 is 16. So that's 1, 2, 3, 4 2's. So this would be 2 to the 4th is equal to 2 to the t. And so here, the bases are the same now, so my exponents have to be equal. 4 is equal to t. And so that it would take 4 hours for the population of this bacteria to reach 16,000. And then the last part of the question says, how many bacteria would there be after 5 hours? So here I'm going to let t equal 5 hours. And we're looking for what is P of t. So here, P of t would be equal to 1,000 is our initial value. And then we know that this is 2. And here they're telling me that my time is 5 hours. So this would be 1,000 and then 2 to the 5th using my calculator. I have 2 y to the x 5 equals 32 times 1,000 is equal to 32,000. So this is basically how you work, and this is called an exponential growth. Okay, now let's look at another problem like this. And sometimes they just come out and give you the formula. So they give you the formula that P of t is equal to 100,000 e to the negative 0.03 t. So we have 1,000 e to the negative 0.03 t. This is the function that they have given us. When we're looking at this, they're going to ask us, what is the population after 5 years? Okay, so, and there may be some little story like the population of this city is 100,000 people, and this is the growth rate that we're expecting. What is the population going to be at the end of 5 years? But notice, you don't have to worry about all the words in the problem. All you have to worry about is, here's the formula, plug in 5 for t. So it is a word problem, but really, since they give you the formula, it's not a hard word problem. So this is just going to be the new population at the end of 5 years would be 100,000 e to the negative 0.03 times 5. Now, I would recommend that you go ahead and do this part on your calculator first. So multiply the negative 0.03 times 5 first. And that gives you negative 0.15. Once you've done that, then we're going to multiply this in. Now on this calculator, I'm kind of going to do it backwards, because this calculator, you can't just type it in. You have to do it, it's almost backwards from what you want to do. So this is going to be e to the negative 0.5. So I put the negative 0.05 in there. And then notice there's a little e to the x right over ln is e to the x. So I'm going to have to use, because it's in green, I have to use my second green button. And I'm going to do e to the x. So that is this number e that we'll talk about in the next lecture. But that's e to the x. And then I'm going to take that and multiply it by 100,000. So I'm going to go times 100,000 is equal to, and so that gives me 860,000, excuse me, it's actually going down, 86,070.7 or 0.8. And so the new population for this city or for this bacteria or whatever it is going to be 86,070.8. And they'll tell you how to round it off. Okay? Problem number 3 says that there is a cost function. And the cost function and notice that this is negative, so the cost is going down. This is a depreciation of, like, let's say that it's, you buy a boat and you can write it off on your taxes. And you get to see how much the boat is worth after so many years. And so the original cost of the boat is here. This is the rate of depreciation, and this is how many years, because all of this is usually written as an annual rate. Okay, so on this one, it says that the boat originally cost $10,000. So that would tell me that C0 is the initial cost. That would be the $10,000. And then it says the rate of depreciation is 2.5%. So here R would be equal to 2.5%. Now, 2.5% means percent, means divide by 100. You can almost see it in the little symbol that they use for it. You're saying divide it by, and then here's your 2 zeros. So this would be 2.5 divided by 100. Now when I divide by 100, my number is going to become smaller. So I'm going to move my decimal place to make my number smaller. I don't like to say move it to the right or move it to the left, because that doesn't mean anything to me. But if I say make my number smaller, when I divide by 100, I'm making it smaller. So I'm going to move it over 2 places. There are 2 zeros here, so I'll move it over 2 places to make my number smaller. So this would be 0.025, and this is the number that I'm going to use for R in the formula. And then they say they want to know what would the cost of the boat be after 5 years. And again, if this is an annual rate of depreciation, then this has to be in years. And so my cost would be 10,000 times 1 minus 0.025 raised to the 5th. And so I'm going to do a little bit of the calculations here first. Well, you can just do it, but I'm going to do it a little bit at a time. So I'm going to do 1 minus 0.025 gives me 0.975 raised to the 5th. So now this is going to be 10,000 times 0.975 y to the x 5 equals. And my answer is, at the end of the 5 years, my boat would cost $8,810.96 if I round it off to the nearest penny. And so here's your answer on the cost of the boat. So all of these, they kind of give you the formula. And in the first one, they didn't really give the formula to you, but if they do not give you the formula, and this formula is on your formula sheet, it's a population is equal to the initial population times the rate of growth or decay raised to the t time. All right, so this is part 1, exponential growth and decay.